Hello, welcome to this new video for you guys. In this video we are going to analyze what is the negative of a digital image, and you are going to learn which is the theory behind this transformation, which is very simple. You don't have anything to be worried about. And we are going also to analyze how to programming in MatLab, how to compute a negative of a digital image. In this slide we have the explanation how to compute, how to understand what is a negative of a digital image. As we can see in this example image, this image was taken from this classical book. We can see that this transformation, it means about how to invert the grade values of each pixel of the image. For example, we can see in this area a very dark gray level. Otherwise, in the output we see these areas with a brighter color, with a brighter grayscale level. So we are talking about inverting. We are talking about making a complement of this image and having this result. How can we achieve this? We can achieve this result using this math expression, in which we have the input image f and we have the output image g, and the operation is very simple. We are just making a subtraction of 255 from the original image. Just important to keep in mind that we are talking about 8 bits images, which means we have 255 levels. So that's why it's 255 here. So if we see the graph of this gray level transformation, is this graph we are seeing in this side, and in the x-axis we have the input image f, and we can see how in very simple straight line with a negative slope, how each value has its corresponding according to this mathematical expression. For example, for very dark areas in the first topic I told you, we have 0 values, and at the output we can see 255, which means the maximum white color in this image. So it's very simple this transformation from this explanation. So now we are going to see some MatLab example, some MatLab codes in order to make easier for you to implement this transformation. Now we are in MatLab. I'm going to run this code line by line to show you how to compute the complement of an image. Fortunately, MatLab has an inbuilt function, but also I'm going to provide you an implementation of a function that performs the same operation. So let's get started. Okay. In this part this is just to clear the command window, to clear variables, to close whatever. This is just something stylistic that is very common to use in MatLab. So in this first line we are reading the image, the example image. This image we have here, we are reading the same image, and wait a second. Okay, and we are going to store this image in this variable. So if we want to run this line, we just highlight the line and press F9. Okay, and we can see this line is written down in the command window and is executed. So what happened? We have in our workspace the variable im, in which the image is stored, and also we have the dimensions, the type of the variable, we have the maximum and minimum and whatever you want to add here. So if we want to see the image, we need to run this line feature. We are going to open a new feature. We are going to show the image, and we are going just to add a title to that image. So let's gonna run this line F9, okay, and we have the image we have been seeing in the example. We have the original image is an X-ray image, and okay, let's continue. So we have two options to compute the complement. Okay, the first option I am showing to you is a function, an implementation I performed, which is called imNegative. Okay, we can see here in this folder a function with the name imNegative. With double click, we open this script, and we have here the instructions associated to that function. Okay, so what does the function perform? It's it's computing negative, but first I just want to, okay, it just receive the image as a input parameters, and it also returns the negative of the image as an output parameter. But I want to stress that this first line we are seeing here is a conversion of the image into UINT8 format. Okay, it's like making sure that we are dealing with 8-bit images before applying the math transformation, because this is it's very important to do that, because if we don't know what type of image is very important. It is crucial to highlight that we need to use an 8-bit image before applying our transformation. So the transformation is just computed in just one line, in which we have 255 subtracted from the image, and we have finally the output image in negative. Okay, this came from this. I mean, we are seeing that because this is the definition of this kind of transformation. We just implement this mathematical operation in MatLab. Okay, I just also want to highlight, because people sometimes when we are learning from other languages like C, C++, or whatever, we have the point that sometimes we need to implement two loops in order to make image operation. I mean, if we want to make a subtraction for each pixel, we want to make we used to make two loops to perform this. But in MatLab it's not necessary. You cannot do that, because it's it's better to performing it just in one line, because MatLab assumes that this is a matrix, and automatically it will execute this value from each pixel of the image. So on that way is an advantageous point using MatLab for image processing. So finally, this is the implementation. We run this code. We just press F9, and we have here an inbuilt MatLab function with the name is imComplement. We also run this line with F9 again, and finally I am opening a new feature. I'm going to show two images, the result from our implementation and the result from MatLab, and we're just going to make like a kind of visual comparison in order to check out if everything is alright. Okay, and just F9 again. Okay, and we have here the comparison among two results. As we can see, the both results are equals, and we can ensure that we have correctly programmed, we have correctly understood how negative image, how we can compute how we can perform this simple basic grayscale transformation on image. So I hope you have liked this video. If you want to keep receiving this video, just subscribe to the channel and we keep on contact. Okay, bye bye.